Hello students, welcome you all to the session of Solutions for GATE 2023 Engineering Mechanics subject Mechanical Engineering branch. So moving on to the very first question of Engineering Mechanics. The option shows frames consisting of some rigid bars connected by pin joints. So you can clearly see the pin joints here, right? See the pin joints. Which one of the frame is non-rigid? A, B, C, D. He has given you four options here. Guys, non-rigid frame. What do you mean by non-rigid? Rigid in the sense, whenever you apply some load on your member, obviously it should not deform. Then we call it as rigid condition. If we are talking about non-rigid conditions, the relative motions between the joint should be large, right? The in between these joints, the relative motion should be very high, so that we call it as non-rigid motion. So when we are talking about options A, B, C, D, when we are talking, there are four different trusses there. When you talk about A, this truss, see all the joints are off bend and clearly this is a stress truss. We people know that this is a stress and obviously we call this as a rigid structure, right? When coming to B, again this is also a rigid truss, right? As all the pin joints are being in contact to your members. Come to option C. Here in case of C, what happened? You all are your pin joints, but when we talk about a certain force acting on this point, let P be this point. As there is no support between these blocks, what happens? There will be a deformation. There will be a deformation in this truss in this manner, right? So obviously this will be delta, that is nothing but delta or delta L, the deflection. So the force on the member C option, when we are talking about, whenever we are talking about this member, there will be a particular force which will be acting at point P that will always make the deflections or deformation. So we can clearly say that option C will be the right answer for this question which is been given, because there will be a particular deflections of point at point P load which is being applied, right? So what will be the answer here? The answer will be option C. Option C will be the right answer for the given question. Moving to the next question. A spherical ball weighing 2 kgs is dropped from height of 4.9 meters onto an immovable rigid block as shown in the figure. If the collision is perfectly elastic, the question is from elastic collisions, which is what is the momentum vector of the ball in kg meter per second just after the impact? Take acceleration due to gravity to be 9.8 meter per second square. Option has been options have been rounded off to one decimal place. When we are seeing this, there is some 2 kgs mass which is being dropped on this block, and the acceleration due to gravity will be g. The angle here is 30 degrees. So when you draw a free body diagram representing a vector form I and j here, the diagram looks like this. This will be the rigid surface. Angle here is 30 degrees, right? Let the height here be h from the ball where it is dropped down, right? And the angle normal be this, This is angle 30 degrees. Velocity V is this. Let it be angle theta. This is nothing but line of impact. This is nothing but line of impact, making an angle of 30 degrees. Now, here let this theta be angle about line of impact through which the ball will be moving out. U is the velocity, right, in the vertical downward direction. If I take, that is the velocity in the downward direction, U, right. So the height here is around 4.9 meters given to you. From here, I know that U is equal to root 2 GH, right? So velocity U equal to root 2 into 9.81 into H, 4.9, which will lead up with an answer of 9.8 meter per second. Am I right? Now, what he is saying, he has clearly given that the perfect elastic collision E is equal to how much? For perfectly elastic collision, E will be is equal to 1. So obviously, the velocity when we are talking after impact, the ball will come hit the body and it will reflect, right? So obviously, the velocity of approach when we are talking, velocity of approach, we write it as what? It is making an angle of 30 degrees. So U cos 30 degrees minus 0. Why I am writing 0 there? The block is rigid, right? So velocity will be equal to 0. So relative velocity of approach will be around, if you have any confusion, write it as relative velocity. Relative velocity of approach is U cos theta minus 0, which will be U cos 30 degrees. Now, approach is fine. Then again, what about the separation after the impact? When we are talking separation after the impact, you will be getting it as V cos theta minus 0, which will be V cos theta, right? So this is equation number 1. This will be equation number 2. Equated. U cos 30 degrees is equal to V cos theta, right? So from there, equations 2 and 3, or we took it as 1 and 2 here, right? From 1 and 2, V is equal to root of U square cos square 30 plus U square sin square 30, right? From here, find the value of V. Find, because we know that U is equal to 9.8 meter per second. When I substitute, you will get a value of 9.8 meter per second. V equal to 9.8 meter per second, right? So again, we can write it as, from your equation number 1 and 2, we will be writing it as tan theta is equal to tan 30 degrees. So obviously theta will be is equal to 30 degrees, right? So what happens when we are talking about the inclination conditions? Here theta is 30 degrees, which you got. This is 30 degrees. So obviously the rest pending angle from here to here, it will be 60 degrees, right? So inclination of the plane of section, we call it as 90 degrees minus 30 degrees, which will be 60 degrees, which will be 60 degrees. So now we can clearly write it as PS, the momentum, mv cos 30 degrees into I cap plus mv cos 30 degrees into j cap, right? So obviously you will have around 17 I plus 9.8 j. 17 I plus 9.8 j. That is nothing but option C will be the right answer for the given question here. A simple question from collisions, that to elastic collision, E will be is equal to 1. Moving to the next question. Area moment of inertia about the y-axis of linearly tapered section is shown in the figure is dash meter per 4. answer in integers. A tapered cross section area is given to you there, where the total width will be 6 meters, tapered round to 3 meters, the length is around 12 meters, right? So what happens? This is symmetrical about x-axis, am I right? Symmetrical about x-axis. So when I draw the diagram for this, so this is the condition. B, C, O, A, B, C, D. This is 1.5 meter given to you. This is 1.5 meter given to you, for example. This is 3 meters, right? So when I take moment of inertia of rectangular section OABC, half base into AB whole cube, right? That will be 1 by 3 into 3 into 12 cube, right? Because this OA is how much? 12, right? Given to you in the question, no? So obviously from here you will have 1728. 1728. Now I am taking the triangular section BCD. This happens as IDC is equal to 1 by 12 DC into BC whole cube. 1 by 12 DC is 1.5, BC is 12 whole cube. On calculating, you should get around 216. So IYY IDC minus, or else I can take IOC minus IOC minus IDC. OC is how much? 1728 minus DC is 216. Obviously, you will be getting 1512. So when we are talking for the whole tapered section, IYY will be is equal to 2 times IYY dash. Let it be dash. That will be 2 into 15 into 12, 1512. That will be 3024 meter per 4. That is your integer which you need to take it into consideration. How much? 3024 meter per 4. By this we have completed the questions of engineering mechanics subject. Engineering mechanics subject from GATE 2023 mechanical engineering. Hope you people have understood. Thank you, students.